In section 2.1, we're going to look at different ways, and it's just kind of an introduction into functions, and you've probably seen this before, especially in Algebra 1, where you have an input, which is your x, you apply a function to it, and then you get a certain output. So today we're just going to basically review some of those different aspects, different terminology when dealing with functions. And then tomorrow in section 2.7 that we look at, we're going to look at special types of functions, the absolute value functions and graphing those. So this is just kind of an introduction into relations and functions. And the first thing we're going to look at is different ways. There are basically 4 ways we can represent functions and relations. The first way is by just listing a set of ordered pairs, x and y, and so on. Second one is a mapping diagram, which takes the inputs and lists them in one circle, outputs in another, and just draw arrows from input to output, mapping. The other way is a table of values, and the last way is a graph. So we're going to look at all 4 of those ways with this first example that we're dealing with. Okay, when skydivers jump out, and this is the first example on your example worksheet, when skydivers jump out of an airplane, they experience what's called free fall. They just drop to the earth. And this picture shows relationship between certain time and how high they are. Now, again, we've talked a little bit about independent and dependent variables before. And just to review that, the dependent value, or the value that depends upon the other one. So what makes more sense? Does time depend upon how high they are? Or does their height, or how high they are, depend upon how many seconds have passed? Well, obviously the second one makes more sense. The height depends upon how long they've been falling. So that makes the height the dependent value. So this value is the dependent value in each of these ordered pairs. Okay? That makes the time the independent value. So therefore, the time comes first, height comes second. So now in order to represent this in different ways, okay, the 4 different ways to represent this, which is what the example is actually asking for. The first method is ordered pairs. So we set those apart with braces, and we're going to give them the ordered pairs. And the time always comes first. And after 0 seconds, they were at 10,000 feet. That's one ordered pair. Next ordered pair, as I look back, next seconds, or the next time is 4 seconds, and they were at 97.44 feet. So that's the next ordered pair, 4:97.44. Then the next time is at 8 seconds, and that's 89.76. So 89.76. And then the next one is at 12:76.96. And finally, the last one is, I believe, at 16 seconds, 59.04 feet. So 16:59.04. So that's a set of ordered pairs. That is one way to represent this relation. The next is what's called mapping. So the mapping part of it is we're going to put the inputs in one circle, and the inputs is the time, the independent values. So the input in 1, so that's the 0, 4, 8, 6, or 12, and 16. Order really doesn't matter. And then in the other circle, we're going to put the outputs. So then the outputs are the heights, the 10,000, the 9744, the 8976, the 7696, and the 5904. And then we just draw arrows from the input to the output. And that's the mapping that's going on. And this is called the mapping diagram for this particular relation. And the next one is a table. And you can make a table that relates the time to the height. And the times that we have are the 0, 4, 8, 12, and 16. And right across from there goes our heights, or the outputs, 10,000, 9744, 8976, 76, 96, and finally 5904. So that's the table. So we've got 3 of them so far. The ordered pairs, the mapping diagram, and finally the table. And finally, the 4th is the graph. And as we talked about before in the last unit, that generally we put the independent value on the horizontal axis. So this is time, which means then the dependent value, or the height, belongs on the vertical axis. So then we can put our times along here, 4, 8, 12, and 16, and our heights here, and we can maybe go by 2000s, 2000, 4,000, and so on. So that puts 10,000 up here, 6,000 and 8,000. And then to graph these, we just graph each ordered pair, 0 and 10,000. Next one is 4 and 97, which would be, again, very close. 8 and 89, be about down here. 12 and 7696, which is kind of close to 8,000. And finally 16 and 5904. Okay. Notice how these are not in a line. It's a curve. What happens is the longer you fall, the faster you fall. You're falling towards the earth is not at a constant rate, because the longer you fall, the faster you go, because gravity's been acting longer. So those are the 4 ways we can represent the relation. In the next video, we'll talk about domain and range.